Welcome to the presentation of section 4.6a, part 2. It's about the graphing of cotangent, so let's dive right in. All right, cotangent is very similar to tangent, and I want to draw a really quick sketch of tangent over here. If you'll recall, it ends at pi over 2. It starts at negative pi over 2. This is just the first period that we draw right around the origin. And it has asymptotes at those two values. So I'm going to draw asymptotes here. Remember, these are guides to drawing it well because it falls entirely in between these two lines. So the pattern included the two asymptotes on either end, and then in the middle are 3 dots. So not a 5-dot pattern, but it does have 5 elements. In the exact middle on the x-axis we have a dot, and then halfway to the left asymptote, we go down to -1 and draw a dot, and then halfway to the right asymptote, well, we don't put it on the x-axis, this is the hash mark right there. Halfway, and that's not even halfway, that's terrible. Halfway to this asymptote, which is at pi over 4, we go up to +1, we draw that dot, and now we can draw our sketch. So from here we go down through this point and head toward the asymptote. Use it as a drawing guide. And from here we head right, we go up through that point and then head. That's a terrible drawing. We're going to head toward the asymptote, and I didn't leave much room up there. So it kind of curves upward like that toward the asymptote. Okay, that's better. All right, so there's tangent. Now, cotangent is a similar shape, but we're going to shift it down the axis over here, pi over 2. Do you remember that cosine is a shift of pi over 2 from where sine sits in its parent function? So one of the relationships that's similar is that tangent and cotangent are only off of each other by pi over 2. So we're going to shift the asymptotes over and start at 0 for cotangent. And this curve is going to get flipped, so the left branch is up and the right branch is down. So let's draw that and see what it looks like. Now these values that you could plot on this curve would come from the unit circle and the compass point coordinates. So 1, 0, 0, 1, -1, 0, and 0, -1. And then if you'll recall, we threw in the multiples of pi over 4, where the tangent was 1 or -1. And that's how we got all of our values. Here it's 1, here it's -1, here it's -1. Oh, nope, there it's +1. And here tangent is -1. And cotangent is the reciprocal of tangent. So when you take the reciprocal of 1, you get 1. When you take the reciprocal of -1, you get -1. So watch this. If this is 0, and over here, 1, 2, 3, 4, 5, 6, 7, 8 would be out here. Okay. 1, 2, 3, 4. I'm going to make that pi. Make that 0. That's going to be one period. Just like tangent has a period of pi, we're going to have one pi as our period of cotangent. And if we graph these points at 0, remember cotangent is x over y, or cosine over sine. So cosine of 0 is, or cotangent of 0 is x over y, 1 over 0, undefined. That's why we are undefined at 0. And so the asymptote that was sitting at negative pi over 2, I told you was going to get shifted right pi over 2, and now it's sitting at 0. When you switch from y equals tangent x, which is what this one is, to y equals cotangent x. Okay, so we're going to draw points at pi over 4, it's 1. All right, and since 4 boxes is pi, 1 box is pi over 4. And then at pi over 2, 0 over 1 is 0. So that's why it's at 0 in the middle. And then over here at 3 pi fourths, cotangent is -1. Just like tangent is. And there's our 3-dot pattern. And then we get over here to the pi radians direction, and -1 over 0, x over y, is cotangent is undefined. And so that's why we have an asymptote here. So can you see that from tangent to cotangent, the asymptotes that were at negative pi over 2 and pi over 2 are now at 0 and pi. And for that reason, I consider cotangent a little bit easier to graph. But you see the same type of three-dot pattern, just going downhill instead of going uphill, okay? These three were sitting here, here, and here. And so when I go to draw this, I'm going to draw the downward one first, and then I'm going to draw the upward one. If you can draw it all in one, that's great, but I find it difficult enough drawing it in two pieces. So just going to head toward the asymptote, but I'm not actually going to cross it. So here is one period of cotangent. All right, because we always graph two periods of everything, I'm just going to duplicate this pattern to the left. I'm going to choose another 4 boxes. 1, 2, 3, 4. Here's negative pi. Make sure you're labeling enough for us to follow it. We'll draw the vertical asymptote over here. And then I will draw my 3-dot pattern in the middle of the period. I'm going to be at the x-axis. Left, I'm going to go up 1 for a shoulder height, and right, I'm going to go down 1 for a shoulder height, and then draw one more just like it. So here is 2 periods of cotangent. All right, let's get some practice changing this graph around. So this is typed funny. Anytime you draw a fraction line as a slash and put numbers on left and right, it's hard to read. So I'm going to rewrite this. Cotangent of pi over 4x. Okay. Now you'll notice that there is no plus or minus another number, plus 0, right? So I actually don't want to even write 0 because there's nothing there, meaning there's no phase shift. I don't have a coefficient here, so my, okay, remember it's not amplitude. I'm going to call it shoulder height. It's the same kind of thing as amplitude. It's this number in front of here, which is understood to be 1. So that's not any different from plain old y equals cotangent of just plain x, which we drew on the previous screen. So period is just like tangent, pi over b. This curve, with no stretches or shrinks, has a period of pi. When we start messing with the period, we have that number in front of x. Remember, this ABC system is built on curves that look like this. A is the multiplier in front of the trig function, B is the multiplier in front of x, and C is related to the phase shift as well as B. So the period is pi over B, and B is pi over 4. So pi divided by pi over 4. So we're going to flip pi over 4 and make it 4 over pi and bring it up and multiply it by pi. So this is pi times 4 over pi. The pi's cancel and give us a period of 4. And there is no phase shift. So when we go to draw this one, we'll put some axes in. Okay. Y-axis. When I go to draw this one, this is going to look like my original cotangent curve, which started at 0 and ended at pi. But it's not been shifted left or right any, so it's still going to start at 0. And that's really hard to see. It's still in red. I need it to be another color. Let's do purple. Okay. There's a vertical asymptote in purple. And maybe in a thicker line so you can really see it. Okay, now I'm not going to go over 4 boxes to pi. I need my period to be 4 wide. So if each box is just 1, 1, 2, 3, 4, it's still 4 boxes. But notice changing the labels does change the value right here that where we're crossing the x-axis is 4 instead of pi, okay? So I've got my asymptotes drawn. I'm going to do my 3-dot pattern in the middle and draw my curve. So in the middle of the period, I'm going to put a dot right in the origin. And my shoulder height is 1, so when I go halfway left, I'll go up 1. And when I go halfway right, I'll go down 1. So here's one period of cotangent. We're always going to draw 2. So I can go left or right. Last time I went left, this time I'm going to go right. So I am going to draw my asymptotes 4 boxes more, so 4 boxes between asymptotes, 1, 2, 3, 4, and put that here. And then I've got to do my 3-dot pattern to draw my next curve. Exactly in the middle, I'm at the x-axis, shoulder height of 1. So when I go left halfway, I go up 1. Right halfway, I go down 1. And I draw my second period. And there we go. There's 2 periods of cotangent of pi over 4x. All right, now we need to see a vertical stretch or shrink to these. So let me draw a couple of set of axes. All right, so here's this one, and then here's this one. We're going to explore what it is to change the shoulder height of these curves. So notice that this does not have a phase shift and it does not have a period change. So I can go ahead and draw in asymptotes where they were on the original y equals cotangent x. 0, and I'll make the period 4 boxes and call that pi. The period is pi because it has not changed from the original drawing of y equals cotangent x, because we don't have a multiplier in front of the x here, so the period is unchanged. Same thing for this one, period unchanged. Make this 4 boxes equal to pi radians, so that the period is 4 on both. And then the 2 is where this is slightly different from the others, still pretty straightforward. I'm always going to start my 3 dots in the middle, right in the middle on the x-axis. And then when I go halfway over to the left, I'm going to go up 2. And then that, because this is 2, because my, technically, you know, we might want to call it amplitude, but it wouldn't be right. It's really the shoulder height. Over here, when we go halfway over to the right, we're going to go down 2. And we have a new guide to draw our curve. So stretching it out a little farther than before. But it's still not a straight line, so please draw a little curve in there, and you'll get your cotangent curve, okay? Got to draw another asymptote, 1, 2, 3, 4, to get my second one in there. Are you getting the hint that drawing the second one is just repeat the same asymptote width and draw the same little 3-dot pattern? In the middle, left, up 2, right down 2, and draw the second one in. Okay, so what in the world does flipping this do? Because over here on the right, we have -2. So it's still going to be stretched out to a shoulder height of 2, but negative means this one is flipped. So I'm going to draw the one I just drew over here, but what's up is going to be down, and what's down is going to be up. So watch this. And let me go ahead and draw that second set of asymptotes, second period in while I'm thinking of it. And that'll make this 2 pi. And then when we do our 3-dot pattern, we always start in the middle on the x-axis. But instead of going over and up for cotangent, we flipped it, so we're going to go over and down. And then to the right, we're going to go up 2. And so we start down where we used to start up. So we have flipped it. And this looks a whole lot like tangent now. But when we flip cotangent, we do get tangent looking curves. That's okay, because this is still -2 cotangent x. Repeat the pattern over here. Going down first and then up. And then we can draw the second period. I think it was a better drawing than the first one, but there's the difference between 2 cotangent x, +2, and -2 cotangent x. Notice the asymptotes, periods, is the distance between asymptotes is still just pi each time. And over here, the shape is the same as it was, except for the shoulder stretch up to 2 and down to -2. That was the big change from the original curve on these. All right. We finally need to see all of these things in one problem. So here goes. Put the axes in. All right. And then we're going to, this is going to take a little bit more. We can do this like we did tangent and solve for where the asymptotes go. See, putting a 1/2 in here changes the width of the period, and then putting a C value in here changes and makes it shifted left or right. So we can do C over B like we did for phase shift with sine and cosine. and then go opposite the sign. We can also try the trick we tried with tangent by setting bx plus c equal to our original cotangent asymptotes, which were 0 and pi. Now, I say what we did originally, it looks a little different. When we did tangent instead of cotangent, we set these equal to pi over 2 and negative pi over 2 because those were the original asymptotes. But with cotangent, the original asymptotes are 0 and pi. So I'm going to let you choose whether you want to do phase shift this way or you want to do them this way. But in either case, you need to draw the asymptotes first. All right, so we still want to do like amplitude, and it's not really amplitude, it's shoulder height. That would be 3 because that's the multiplier here. Period, this is going to be pi over b. B is a half. Pi over 1/2. Flip a half and multiply by 2, and you get 2 pi. So our period has doubled. And then our phase shift, if we're doing it this way, is going to be c over b, pi over 4 divided by 1/2. Let's see what we get there. Flip the 1/2 and multiply. And we've got 2 pi over 4, and 2 over 4 reduces to pi over 2. So we have a phase shift of pi over 2. Opposite the plus sign is minus or left pi over 2. So you can take your basic cotangent curve that goes from 0 to pi and shift it left pi over 2 units. That's how you could use c over b here. The other way you could do this is to say, let's do yellow, 1/2 x plus pi over 4 equals 0, because that's one of the original asymptotes. Solve for x. Subtract pi over 4 off of both sides. It winds up on the right, and it goes away on the left. And then we have to multiply both sides by 2 to get x by itself. So times 2 on the left and times 2 on the right. And that gives us, the 2's here cancel, and we get x. And that gives us negative 2 pi over 4, which is negative pi halves. Well, that's what we got over here, that we're going to go left pi halves. The other one is to take our original expression here, just like we did, bx plus c up here, and set it equal to pi. So 1/2 x plus pi over 4 equals pi. And then to isolate x, I'm going to subtract off pi over 4. I'm going to get 1/2 x equals pi minus pi over 4. 1 minus 1/4 is going to be 3/4 pi. And then I'm going to multiply both sides by 2 again to get rid of that 1/2. So I'll get x equals 6 pi over 4, or 3 pi over 2 reduced. You got to reduce it to really see that. So my brand new asymptotes, when I shift this curve, are going to sit at negative pi over 2 and positive 3 pi halves. So you could just go ahead and draw them in there if you decide to do this problem with this little help. If you want to do c over b, you're going to have to take them from where they were, and they were at 0, and shift them left pi over 2. Well, one of them was at 0. Shift it left pi over 2. So let's make some labels. I'm going to make pi 4 boxes, and you've seen me do that a bunch just because an even number is so much easier here. That makes pi over 2, negative pi over 2 here, and positive pi over 2 here. All right, I'm going to keep going over here. 4 more boxes, and I've got 2 pi. And then halfway between 1 pi and 2 pi is 3 pi halves. That should be enough labels to be getting on with. So my asymptotes, one was sitting at 0, and I'm going to shift it left pi over 2, so 1, 2. And that puts it as a negative pi over 2, which is what this says. So see how you can do either method, and they're both fine. All right. Well, the other cotangent asymptote, before it's transformed, sits at pi. So that's got to go left pi over 2, and it's going to sit here. Pi over 2 is 2 boxes. So see how our asymptotes simply shifted left 2 boxes? Draw this well. There we go. Now, so we have a period of 4 boxes. That's from negative pi over 2 to positive pi over 2, and that's pi. oh, I didn't do this right. I've changed the period. So, okay, we've come up against something we've just learned. Just shifting them left is not going to be enough. So if you were thinking, hey, I'm just going to do this, it's not enough because it didn't account for the period being extra wide. So if you looked at this and said, I don't want to solve equations with pi in it, I want to apologize. This is the way to go. I kind of had to show you that C over B was going to fail because it doesn't make the period right. And so it's not as simple as C over B, and we want to solve these equations. Notice that while this one is sitting in the right place, when this one was supposed to be sitting at 3 pi over 2, and that was a shift in a different direction. So we can't do that. And I was going to stop and re-record this video when I went, oh, that method doesn't work here in my mind, but I decided to let you see how it doesn't work. So let's erase these wrong asymptotes. All right, right back in my labels. Negative pi over 2 and pi over 2. Okay, and we're going to put the asymptotes at negative pi over 2 and 3 pi over 2, like our work over here said. All right. So, negative pi over 2. Oh, I shouldn't have erased that one. I should have just erased the wrong one. I have a cat that's wanting to sit on my writing tablet, so you'll have to pardon me if this is drawn terribly. She's trying to sit on my hand. Oh, and then she's standing on buttons too. Tigger, baby doll, you have to go down here, please. There you go. All right, oops. All right, so to keep up, this asymptote was where it belonged. And then the other one is at 3 pi over 2. So it's wider than it was. And that's 8 boxes wide, so I've got to do 8 more to do a second period. I'll do that to the right. Wait a minute, gotta get rid of the cat again. I love you, Tigger, but you have to go away. Thank you. All right, 1, 2, 3, 4, 5, 6, 7, 8 is where the next asymptote is. That makes the periods the same width. I'm going to kind of put some labels to keep up with this. So this is every 2 boxes is going to be another pi over 2. So 5 pi over 2, 3 pi. Okay, so we've got some labels so you can tell where that is. And now I just have to do my dot patterns, okay? So exactly halfway between these two is 4 boxes in. We sit on the x-axis. And this is plain old cotangent, not flipped, so if I go halfway to that asymptote, I'm going up 3. And on the right side, if I go halfway to that asymptote, I'm going down 3. And then I'm going to draw it in. All right, and then this one halfway, 1, 2, 3, 4 on the x-axis. Halfway to that asymptote, go up 3. Halfway to that asymptote, go down 3. And there we go. There's 2 periods of 3 cotangent, 1/2 x plus pi over 4. So tangent and cotangent take some practice solving these little equations to find where the asymptotes go, but it's the only challenging part. Once you get comfortable with those kinds of equations and dealing with pi fractions in an equation, then drawing the asymptotes is your first step. Then putting the curve in with the proper shoulder height gets the rest of the question out of the way. So if you can develop a comfort level with solving these little 2-step equations, then you can graph tangent, cotangent pretty easily, and all it takes is practice. Okay? Thanks for listening.